Okay, hello everyone. Uh, Today I will show you the some examples on technique of integration, especially the trigonometric substitutions. Okay. If you have this kind of functions or integrations, what we can do here is look at this. Okay, see if you can do some completions in complete the standard form. Okay, so standard form means is, let's say we have the x squared plus 2x plus 5. Okay, now if you remember the quadratic equations, this probably will be x squared plus 2x plus 4, right? Not 4 plus 4, sorry, plus 1 plus 4. Okay, now the whole thing here, x squared plus 2x plus 1, we can rewrite as x plus 1 squared. Okay, now the whole thing for these integrations we can rewrite as okay. Now we have variable, right, and then squared and then plus a constant, and we can also think of, if we have tangent squared plus 1, this will be a secant squared x, right? So a good way to approach this is by using some, so let x plus 1 is become tangent, let's say theta. Okay, and when we are letting the x plus 1 equal tangent theta, we can also evaluate the derivative, or in this case is 2 tangent theta because the constant is 4. So this will be 2 secant squared theta. Okay, if we are going to put 2 tangent theta here, this will be 4 tangent theta squared. So this will be 4, this will be equal 4 secant squared theta. And if we are going to square root this, this will be resulting to secant theta. Okay, now we have the x will be 2 secant squared theta over 2 secant theta, or we can have, this is integration of secant theta d theta. As we mentioned in class, these integrations resulting in ln secant theta plus tangent theta. And let's say this is plus c1. Okay, or you can ignore the c, and then because we have the result in theta, but the questions is in the algebraic form x, right? So we need to remember to change the theta into the algebraic forms. How we are going to do, we can do with our with our triangle. Okay, we have a theta, a tangent is so tangent theta is x plus 1 over 2. So x plus 1 here and 2 is here, and we have in this is plus 4, or this is our questions actually, right? So this is x squared plus 2x plus 5. Okay, now secant is the whole thing here over 2, and tangent is just x plus 1 over 2. So we can write the equations is ln x squared plus 2x plus 5 over 2 plus x plus 1 over 2, and then plus c. Okay. However, you can also, so if you are writing this is plus, let's say c1, and then you can also write this in terms of, because sometimes solving with other methods or different calculations will resulting a different result, and that's okay in integrations because of we have a different constant. Okay, now if we let this this is still c1, okay, we can exchange this with c, where the c is c1 minus ln2. Okay, so that's why the constant is really powerful. It's really important, so don't forget to write down the constant whenever you integrate some integrals. Okay, now that's the first exercise. Okay, I hope you get everything clear. Okay. Okay, now second one I want to show you is probably here. Oh no, do maybe this maybe this first. Okay, so we are going to look at x squared plus 2x. Okay, and imagine it's being a complete quadratic equation, which is having a plus 1, and let me add minus 1. Okay, so this will be resulting in this minus 1. Okay, so we have something squared minus a constant, which if we remember, this will be a secant, right? If we take down. Okay, and then the other integrations, we have square root of x plus 1 squared minus 1, and then dx. Okay, now let our x plus 1 become a secant. Now we can have dx is secant theta tangent theta d theta. Okay, now if we compute this, if we compute this secant square theta minus 1, it will be tangent square theta, or it will be a tangent theta. Okay, so we can have integrations tangent theta, okay, and dx will be secant theta tangent theta d theta. We can have a tangent squared theta secant theta d theta. Okay, and I think we can substitute tangent squared with the secant squared minus 1, and then this will be a secant theta d theta. Okay, and we can have secant cube minus secant theta d theta. I think I have give you some explanation about secant cube, but let me just write down the methods. Okay, let me write using the black color. Secant cube theta d theta. This we have, let's write di. I think we can have a secant squared here and secant theta here. We differentiate, becomes secant theta tangent theta. Okay, if we integrate this, this will be a tangent theta. Let's stop this and write down the formulations. So this will be tangent theta secant theta minus tangent squared theta secant theta, or we can write down from here this is secant, it's the same actually, right? So this will be secant cube theta minus secant theta. Okay. Okay, let me write completely. Okay, we can move this part, so we can have 2 secant cube theta d theta, and this will be plus secant theta is ln secant theta plus tangent theta. Okay, this is plus c, and we can compute this and divide this by 2. So let me write completely. This is half secant theta tangent theta plus half ln secant theta plus tangent theta plus c. Okay, this is secant cube. And then we need to minus with the this is just a secant cube, right? We have secant cube theta d theta, minus secant theta d theta. The secant cube is this, okay? So half secant theta tangent theta plus half ln secant theta plus tangent theta minus this is ln secant theta plus tangent theta. And then let's say this is a C2, okay, this is C1, C2, okay, to make it the difference, okay? And half and minus, we can have okay. Well, that will be the results. But again, we have a theta, right? So what we are going to do, we will use our triangle. Let's say this is a theta. Remember that secant theta is x plus 1. So cos theta is 1 over x plus 1, right? So cos will be 1 over x plus 1 is this hypotenuse. And this side here will be x plus 1 squared minus minus 1, right? Or this will be resulting x squared plus 2x. Okay. Now we have a secant. Secants mean this is just x plus 1. Tangent means this is x squared plus 2x, and then minus half ln x plus 1 plus x squared plus 2x. And let's say this is still C2. And yeah, I think we can stop until here. Okay. Or if you want to factorize this half, also fine. I think no difference. Okay, that's the trigonometric substitutions. Let me get you to not this. Okay, this one. Okay, the idea is still the same. It's still similar, so you need to just compute this. The quadratic formula, you need to tweak it out. And if you write, or if you look at this, okay, what kind of formulations that you will have, okay? So probably we can start with factorizing the minus here. If the sign is bothering you, okay, or it's like a trouble for you. So we have this will be x squared minus 2x. Okay, let's have from here. Okay, and x squared minus 2x, if we have the formulations, this will be plus 1, right? And minus 1 like that. So this will be resulting x minus 1. Okay, and then minus 1, let's take outside. Then the whole thing will be 4 minus x minus 1 squared. Okay, so this will be the square root. This is x squared. This is the forms. Okay, and remember, you have a constant, you have a variables here. Remember that we can have that, or we can have this. You can choose which one you want. Okay, let's say we are choosing the x minus 1 become sine, so 2 sine theta, okay, because of the 4. Okay, it's this 2 squared, right? So we have 2x is 2 cos theta d theta, and we can exchange the whole thing. So 4 minus 4 sine squared theta square root, and this will be result 4 cosine squared or 2 cosine theta. And don't forget, we still have x squared here, so we will have 4 or x squared will be going from here. X is 2 sine theta plus 1, and we need to square this, so it's a little bit complicated, but I assure you that this is we can still solve it, although it's really long. So we will have, this is squared, this is 2 cos theta, and then multiply with 2 cos theta, and then d theta. Okay, I think you can try by yourself to solve this and see how long it will be. Okay, and I think that's it for just additional work on trigonometric substitution. So you can also rewrite the form in the quadratic formula and write in a complete standard form. Okay, so that's it for additional video. I will add another additional video maybe next week. So always check your Google Classroom, or yeah, I think that's it.